Welcome back to Tandai's Linux. If you've been following the Linux kernel development cycle at all over the past couple of months, you know that Linux 7.0 is right around the corner. And today, we're doing a proper final preview specifically from the perspective of system administrators and IT professionals. Not just what's new, but what actually matters, what you should be testing right now, and how to think about your upgrade timeline. So let's start with where we actually are in the release cycle, because this is important context for everything else we're going to cover. On March 29th, Linus Torvalds released Linux 7.0 RC6. And if you read his release announcement, you'd notice that his tone was a little more cautious than usual. He wrote, and I'm quoting here, "It turns out that RC5 finally starting to calm things down. This release cycle was a mirage. With RC6, we're back to many more fixes than are normal for this time in the release." Now, that might sound alarming, but let's put it in context. Linus also said that most of these fixes are very small, and none of them strike him as particularly scary. The areas getting the most attention are file systems, specifically ext4 and XFS, along with some x86 platform fixes for Intel TDX and AMD EPYC virtual machines. And a lot of audio hardware quirks for laptops. Drivers only account for about a third of the changes. The rest is a mix of core networking, architecture updates, memory management, and tooling. So what's driving this higher than normal fix count? Linus actually offered an interesting theory. He speculated that AI coding tools might be getting better at catching trivial but real bugs, which is actually a fascinating observation about where kernel development is heading. More eyes on the code, even if some of those eyes are artificial, means more fixes get caught before the stable release. The current timeline looks like this. If things settle down, RC7 should land around April 5th, and the stable Linux 7.0 release would follow on April 12th. If the fix volume stays high and an RC8 is needed, we're looking at April 19th. Either way, we're talking about mid-April for the stable release. Now, the question I know a lot of you are asking is RC6 stable enough to test right now? The honest answer is yes for testing environments. If you have a staging server, a lab machine, or a non-critical workstation, this is the right time to start validating your workloads against the new kernel. You want to catch any compatibility issues before your production systems are affected. But for production, no, not yet. Wait for the stable release and ideally wait for your distribution to ship and validate it. Let's also address the version number itself because I know this comes up. The jump from 6.x to 7.0 is not driven by one massive architectural overhaul. Linus has been clear about this. He simply prefers to keep the minor version numbers from getting too high, so he bumps the major version. We saw the same thing with the jump from 4.x to 5.0 back in 2019. Here's the thing, even though the version number is somewhat arbitrary, Linux 7.0 is genuinely a significant release. And the most symbolically important change is this. Linux 7.0 officially concludes the Rust experiment. The Rust programming language is no longer labeled as experimental in the kernel. Following a consensus at the Linux Maintainer Summit in December 2025, Rust is now a core part of the kernel and is here to stay. It is the second official kernel language alongside C. For sysadmins, this matters in the long run. It means we can expect more drivers and subsystems to be written in Rust over time, which brings memory safety guarantees that C simply cannot provide. Fewer buffer overflows, fewer use after free vulnerabilities. It's a slow shift, but it's a meaningful one for the long-term security posture of Linux systems. All right, that's the state of the release. Let's get into the actual features that are going to impact your day-to-day work as a sysadmin. Let's talk about the 5 features in Linux 7.0 that, in my opinion, matter most if you're managing servers and infrastructure. I've deliberately filtered out the hardware enablement stuff, the new laptop driver support, and the gaming-specific changes for now. We'll touch on those later. This chapter is about what's going to impact your production workloads. Number 1 on the list, and this is the one I'm most excited about, XFS Autonomous Self-Healing. If you're running XFS on your production servers, this is a significant development. XFS is getting real-time health monitoring and automatic detection and repair of file system corruption. Here's how it works. A new infrastructure called FS Error provides a generic way for the kernel to report I/O errors to user space. XFS hooks into this infrastructure and creates an anonymous file descriptor that can be monitored by a new user space daemon called XFS_healer. This daemon is managed entirely by systemd. It gets auto-started by a starter service that uses for notify, and it reads health events from the kernel, then initiates repairs automatically. Critically, it won't block unmounting of the file system unless repairs are actively in progress. Think about what this means in practice. Instead of waiting for a file system check at the next reboot or manually running XFS_repair after detecting corruption, the system can now catch and address issues proactively. For high availability environments, this is a meaningful improvement. Number 2, ext4, concurrent direct I/O write performance. If you're running database workloads, particularly anything using the O_DIRECT flag, you'll see better performance here. The improvement comes from deferring the splitting of unwritten extents to I/O completion rather than doing it upfront. This reduces lock contention when multiple threads are writing simultaneously. It's not a dramatic headline number, but for I/O-intensive workloads, it's a real, measurable gain. Number 3, file cache memory reclaim 50 to 75% faster. This one has a very clear benchmark behind it. Developers allocated 10 gigabytes of file-backed data in memory, and then reclaimed 8 gigabytes of it on a 32-core ARM64 server. The improvement in reclaim speed was between 50 and 75%. For systems that operate under heavy memory pressure, like file servers, database servers, or anything doing large in-memory data processing, this translates directly to better responsiveness when the system needs to free up cache memory quickly. Number 4, ML-DSA, quantum-resistant kernel module signing. This is a forward-looking security feature, but it's worth understanding now. Linux 7.0 introduces support for the module lattice-based digital signature algorithm, which was previously known as dilithium before standardization. Initially, this is being used for kernel module signing, replacing RSA and ECDSA. And in the same release, SHA-1 module signing support is being removed entirely. The reason this matters is quantum computing. Current cryptographic algorithms like RSA are theoretically vulnerable to attacks from sufficiently powerful quantum computers. ML-DSA is designed to be resistant to those attacks. For most environments today, this is a future-proofing measure rather than an immediate concern. But for organizations with long security horizons, compliance requirements, or sensitive workloads, it's good to know this is being addressed at the kernel level. Number 5, the extensible scheduler, sked_ext. This is a new scheduling framework that allows custom scheduling policies to be implemented as eBPF programs. For most sysadmins, you won't be writing your own scheduler, but what this enables is a community ecosystem of specialized schedulers that you can load and unload without recompiling the kernel. There are already projects like the SEX Scheduler Collection on GitHub that provide schedulers optimized for gaming, real-time workloads, and server applications. Ubuntu 26.04 is actually retiring the Linux low-latency kernel package in favor of the generic kernel combined with a new user space low-latency tuning package, which builds on this kind of extensibility. These 5 features alone make Linux 7.0 worth paying attention to. But there's more to the story when we look at the performance benchmarks and what this kernel means for Ubuntu 26.0 for LTS. Beyond the individual features, we need to talk about real-world performance, because that's what actually determines whether an upgrade is worth the effort. And the early benchmarks for Linux 7.0 are looking very solid, both on the server side and for desktop workloads. On the server side, Forenix has been running extensive benchmarks on AMD EPYC Turin processors, specifically the EPYC 9755. The results show significant performance gains for database workloads, particularly PostgreSQL. There's also a very noticeable speed up in message passing performance using the StressNG benchmark. These improvements are likely coming from the combination of the scheduler enhancements, the memory management optimizations, and the file system improvements we talked about earlier. They also tested smaller AMD EPYC servers, like the EPYC 4585PX, and found nice performance gains across the board for database workloads. Importantly, they haven't observed any measurable regressions yet, which is a good sign for stability. Now, if you're managing workstations or you care about the desktop side of things, there are some gaming-related improvements worth noting. Linux 7.0 includes fixes for older AMD GPUs, specifically the GCN 1.0 and 1.1 generation, which is the Radeon HD 7000 and 8000 series. Nouveau, the open-source NVIDIA driver, now supports larger pages, which helps NVK, the Vulkan driver, deliver better performance. And the networking stack has received a multi-queue aware version of sh_cake, which is a quality of service improvement that can help with gaming latency. But the real story for enterprise adoption is Ubuntu 26.0 for LTS. Ubuntu 26.04, codenamed Resolute Raccoon, is shipping with Linux 7.0. The beta was released just a few days ago on March 25th. The final release is scheduled for April 23rd. This is a long-term support release, which means it will receive 5 years of standard security maintenance or 12 years if you're using Ubuntu Pro. This is the first major LTS release to ship with Linux 7.0, which makes it the primary vehicle for enterprise adoption of this kernel. And Ubuntu 26.04 is bringing several sysadmin-focused changes beyond just the kernel. First, crash dumps are now enabled by default for both desktop and server installations. If you've ever had to troubleshoot a kernel panic without a crash dump, you know how valuable this is. It's a simple change, but it's going to make debugging production issues significantly easier. Second, Ubuntu 26.04 introduces sudo rs, which is a memory-safe Rust implementation of sudo. This is part of a broader trend toward memory safety in critical system components. They're also shipping Rust core utils, which are Rust implementations of core utilities like ls, cat, and others. Third, systemd has been updated to version 2.5.9 and netplan to version 1.2, both of which bring networking and service management improvements. And finally, OpenSSH now supports post-quantum key exchange using the MLK-EM76 8x25519/SHA256 algorithm by default. This is similar to the ML-DSA module signing we talked about earlier. It's future-proofing the SSH stack against quantum computing threats. If you're currently running Ubuntu 24.04 LTS, the jump to 26.04 is substantial. You're moving from kernel 6.8 all the way to 7.0. That's a significant architectural leap, bringing all the Rust integration, the security improvements, and the performance gains directly into your production environment. So the question becomes, how should you plan your upgrade strategy? Let's talk about that in the final chapter. Alright, we've covered the features, the performance data, and the connection to Ubuntu 26.04 LTS. Now let's talk about the practical side. When should you actually upgrade your production servers to Linux 7.0 and how should you approach it? First, let's be clear about the current state of the kernel. As we discussed in the first chapter, RC6 has a higher than normal volume of fixes, particularly around file systems. While none of these fixes are considered scary, the fact that the kernel is still settling down means you should not rush into production deployments. If you're running a bleeding-edge rolling release distribution like Arch, Fedora Rawhide, or Gentoo, you'll likely see the stable 7.0 kernel by late April. For those environments, I still recommend holding off on updating your most critical infrastructure until at least the first point release, maybe 7.0.1 or 7.0.2. Let the broader community shake out any remaining edge cases first. For enterprise environments, your path is clearer and honestly safer. If you rely on distributions like Ubuntu, Red Hat Enterprise Linux, or SUSE, you should wait for their official releases and their validation processes. These distributions don't just ship the upstream kernel, they backport fixes, they run extensive testing, and they provide support channels if something goes wrong. If you're planning to deploy Ubuntu 26.04 LTS, the beta is available right now. This is the perfect time to spin up a test instance, run your specific workloads, and see how the new kernel behaves with your applications. Pay particular attention to any custom kernel modules you might be using, any third-party drivers, and any workloads that are particularly I/O or memory intensive. For production servers that are currently on Ubuntu 24.04 LTS, I would recommend waiting until at least the first point release of 26.04, which typically comes a few weeks after the initial release. This gives the community time to report any issues, and it gives Canonical time to issue any necessary updates. Now let's step back and look at the bigger picture. Linux 7.0 is shaping up to be a genuinely significant release. It's not just a version number bump. The official inclusion of Rust as a core kernel language, the preparation for quantum-resistant cryptography, the advanced file system features like XFS self-healing, and the performance improvements across the board all point to a kernel that is maturing and adapting to modern enterprise needs. The fact that Ubuntu 26.04 LTS is shipping with this kernel means that these improvements will be the foundation for enterprise Linux deployments for the next 5 to 12 years. That's a long support horizon, and it makes the features we've discussed today even more important. If you found this breakdown helpful, make sure to subscribe to the channel so you don't miss our deep dive into Ubuntu 26.04 LTS when the final version drops later this month. I'll be testing it extensively on various hardware configurations, including some older servers and some newer AMD and Intel platforms. I want to see how the XFS self-healing performs in practice, how the memory reclaim improvements affect real workloads, and how the overall system stability compares to 24.04 LTS. Let's know in the comments which Linux 7.0 feature you're most looking forward to deploying in your environment. Are you excited about the XFS improvements, the quantum-resistant cryptography, the Rust integration? I'd love to hear what matters most to you. Thanks for watching, and I'll see you in the next one.